All right, our DLO for today is I will learn how to graph lines in slope-intercept form. Oops, I probably shouldn't write in red. Let's write in black. Or blue, how about that? I will learn how to graph lines in slope-intercept form. So yesterday we worked on graphing lines. We didn't do it in slope-intercept form yesterday, however. We did it in the two ways of either finding the x and y intercepts and plotting those points, or using a table of values. And so actually those two aren't my particular favorites because slope-intercept form is so much easier than those two are. So our essential question for today is put this equation into slope-intercept form. Then I want you to actually identify the slope and the y-intercept, then graph it. And the equation that I want you guys to be working with is the following equation. 3x plus y equals 2. Alright, so we have only one vocabulary word today. And our vocabulary word is slope-intercept form. So it's kind of a formula and a vocab word at the same time. Slope-intercept form. So the definition isn't really a word definition, it's actually more just the form itself. So the slope-intercept form looks like this. Y equals mx plus b. And you may have heard of this form before. I'm going to put a little highlight on that because it's a really, really important formula that we are going to be using again and again and again to graph lines. You guys are going to use it all the time when you guys get to higher level math classes and things like that. So we already know that M stands for slope. We learned that 2 days ago. And you may or may not know that B stands for the y-intercept. Y-intercept. Now, in this slope formula, if you have y isolated, or in other words, if you have y by itself, you can immediately graph a line just by looking at it. You always start with the y-intercept and then graph the slope as rise over run. The only thing you have to be careful of with the slope is making sure that you have the positives and negatives in line. So when we look down here at the notes, so if you don't have this copied down yet, please go ahead and pause the video to copy it down. Alright, so we're going to look down here at the notes section. And we have some notes to write down for, first of all, before we do any examples. So in order to graph a line, we need to first write the equation in slope-intercept form. And the reason is the reason that we need to do that is because sometimes the equation look differently. Like if you look up at the essential question, because If you look up at the essential question up above, it says the equation is 3x plus y equals 2. And that is not in slope-intercept form because the y is not isolated all by itself. So earlier in the year, we practiced isolating for a single variable or solving for a single variable. And that is going to come in handy very, very much when we start doing these equations because we have to solve for y all by itself. So, for our first example, we only have 4 examples today. So for example number 1, we are going to write each of the equations in slope-intercept form and then graph. So write each equation in slope-intercept form then graph. Alright, so we're going to do the graphs very last. So the first thing we're going to do is we have 5 different categories that we're going to look at. We're going to look at the equation. So the equation that's given, we're going to write it in slope-intercept form. We are going to identify what the slope is. We are going to identify what the intercept is. And then we are going to graph it. So like I said, we're going to save the graph for the end. For right now, we're just going to identify these ones first. So here are the equations we're looking at. So we'll look at the first one. The first equation is y equals negative x plus 2. I'll highlight that because that's our first example. So y equals negative x plus 2. So if you look back up again at the vocabulary word slope-intercept form, it says y equals mx plus b. So from here, all we're really doing is trying to make it look like that and identify what is the slope, what is the y-intercept. So if you look at the definition of slope-intercept form, y equals mx, so there's some number in front of x, plus b, so there's some number either added or subtracted at the end. So if I try to rewrite this, I get y equals, what's the number in front of x that would make x negative? Well, probably a negative 1. So I have negative 1x. So my m would be negative 1 plus b. So in this case, it's plus 2. So that's rewriting it in slope-intercept form. So if I identify my slope, I have m equals, and I always encourage you guys to write your slope as a fraction. So I would encourage you, instead of writing it as negative 1, I would encourage you to write it as negative 1 divided by 1, because that's rise over run. Slope is a ratio of two things, rise over run. So it's always nice to have it as a fraction. And the intercept is just the b that's at the end, so b equals 2. Alright, so here comes the graph. So I'm going to draw a graph. I like to take up about 4 lines with my graph just to make them even and make sure they all fit. 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. Alright, so when I plot these points, I'm going to plot them in red so you guys can see them a little bit better. I am always, I cannot say always enough. You always start with the y-intercept. So since b equals 2, the y-intercept is 2, I'm going to put a point here at 2. That's like my base point. That's where I start from, all right? So if you start there, the rest of your graph will be perfect. A lot of students do it the opposite way. They start with the slope and then they try to graph the y-intercept, and it just really messes up their entire answer. So I want to make sure that you guys are clear that we always start with the y-intercept and then go to the slope. So for slope, it's negative 1 over 1, rise over run, negative 1 over 1. So since it's negative 1, I can go down 1 and over 1 in the positive direction. So down 1 would be negative 1, and 1 in the positive direction would put me right here. So that's down 1 over 1, all right? And I can do that again, down 1 over 1 to get to my next point. So if I put a point here, that would be down 1 over 1. I can also go in the opposite direction. I can go up 1, and that would be a positive 1, and then I can go in the negative direction 1. So either of those work. And when you have those points, you can graph that line by just drawing a line through them. And look how easy that was. All you have to do is look at the equation. Automatically, you know what the y-intercept is. It was 2. Automatically, you know what the slope is, negative 1 over 1, and you can just put it on your graph. So easy. All right, let's look at the next one. So our next equation is y equals x plus 3 over 2. Now this one looks a little bit different because we don't have the variables separated. We have everything divided by 2. So when we split it up into slope-intercept form, I want to divide that 2 and give the 2 to both the x and to the 3 so that we can see that it splits up into 2 separate fractions. So the first one will be 1/2 x. So the 2 goes to just the x. All right? And I write it as 1/2 instead of x divided by 2. Because when you multiply this back together again, 1 times x gives me x on top and 2 on bottom. So that is the same thing as x divided by 2. But I like to write it as 1/2 x because it actually shows me what my slope is. All right, and then if I give the 2 to the 3, I have plus 3/2. So there's slope-intercept form. If I identify my slope, I know that m equals 1 over 2, or rise over run. I know that my y-intercept is 3 over 2. So when I graph this, again, I like to draw 4 lines for my graph. When I graph this, which one do I always start with? The y-intercept. So make sure that you start with that y-intercept. All right, so let's change this back to red. My y-intercept is 3/2, and 3/2 is approximately equal to, or not approximately, it is equal to 1.5. So I'm going to put my y-intercept here at 1.5, which is in between 1 and 2. 1.5 is in between 1 and 2. All right, I have a slope of 1/2, so I can either go up 1 and over 2 in the positive direction. So up 1 and over 2 would put a point here. And I can do that again, up 1 and over 2 would put a point here. I like to draw those little stair steps because I think it helps to recognize what you're looking at as far as up 1 over 2. You can also go down 1 and over 2, so you could also put a point here. And then when you connect those points, they should form a straight line. So if I connect them in purple, you'll see that they form a straight line. Now when you have those stair steps, you actually don't want the stair steps in your final answer, so if you could, go back and erase them, because you don't want to see those little stair steps. So we'll just erase those really quick, just to make sure. I don't want to erase too much or else I'm going to erase pieces of my graph, but you get the point. So yeah, the stair steps we don't want, keep everything but those stair steps. All right, next example. Our next example is y equals -4. So if I rewrite it in slope-intercept form, I notice that there is no x. And if there is no x, it must mean that the coefficient of x, or in other words, the number in front of x, is 0. So y equals 0x minus 4. Because 0x is 0, so that would make sense that that would disappear. So my slope in this case is 0. My y-intercept, or b, equals -4. So when I graph, it looks something like this. I always start at which one? The y-intercept. All right, so we're going to start at -4. So I'm going to put a point down here at -4. And since my slope is 0, it's actually a horizontal line. We wrote that in our notes 2 days ago. So if you go back and look at your notes from 2 days ago, you'll notice that it says that a slope of 0 is a horizontal line. If it's an undefined slope, that makes it a vertical line. But if it's a slope of 0, then it's undefined. I'm sorry, if it's a slope of 0, then it's horizontal. All right, let's go back and highlight some of these equations because these are important equations for us today. And then we have one more example. So go ahead and leave room for one more example. If you need to pause the video to copy this down, go ahead and pause the video real quick because I have to erase this in order to move down so you guys can see my work. All right, so our very last example is this one. Let me change this back to blue. 2x minus 4y equals 16. Now, if you remember, we need to, for slope-intercept form, we need to have y all by itself. So I'm actually going to solve this equation for y. So I'm going to highlight my variable, which is right here. I'll highlight the rest of the equation later, but I'm just looking at my variable right now. So I want to get that all by itself at the very end. So I see that the first thing that's happening to it is that -4 is being multiplied times y, and the second thing that's happening is that 2x is being added to that -4y. So we have to do the opposite in the opposite order. So the first thing we're going to do is we're going to subtract this 2x from both sides. Because if you recognize back up above in the slope-intercept form, all the x's are on the right-hand side. So these cancel, those are additive inverses. I get -4y equals -2x plus 16. I'm not allowed to add those together because those are not like terms. The next thing I want to do is I want to divide by -4 on both sides, because I want to get rid of that -4 that's with y. These are additive inverses, so those, multiplicative inverses, so those cancel to 1. And I get that y equals -2 divided by -4, because I want to split up that -4 to both of the terms. So -2 divided by -4 plus 16 divided by -4. So I'm splitting up that -4 to both terms. So when I come over here to write it in slope-intercept form, I have y equals, well, -2 divided by -4 is positive 1/2 x. So there's my slope. And 16 divided by -4 is -4, so -4. That's my b. So m equals 1/2, and b equals -4. So when I go to graph, it looks like this. And I always start with what? The y-intercept. So my y-intercept is at -4, so I'm going to put a point here at -4. And then I'm going to do my slope, which is 1/2, my rise over run. So I can either go up 1/2, put a point there, up 1/2, put a point there, up 1/2, put a point there, or I can go down 1/2 and put a point there. And then when you connect those points with a straight line, you get your answer. And then I can go back in and I can erase my little stair steps again. I don't need those. That just helped me to figure out my slope. All right, and then that is the end of the notes for today. So make sure you have all of your equations highlighted. Just as a quick review, you have to put it into slope-intercept form, meaning you recognize what the slope is, recognize what the intercept is. You always graph by starting with the y-intercept and then plot the slope points. So let's actually write one more quick note about that. So in order to graph plot the y-intercept first, then the slope points. All right, that's all for today. Maybe go ahead and highlight that last part again just to make sure that we're all good there. And then we will see you tomorrow.